Hi guys, this is day 3 of the 30-day A2 Economics Revision Challenge, and today we're doing indifference curve. When we look at utility theory to look at consumer choice and find out the combination which can give a consumer the maximum possible satisfaction from a given income, which is the primary goal of a consumer, is to maximize his utility. The problem that happened with the utility theory was this, that the utility theory assumes that we can measure utility. Now, in reality, this is not true. In reality, we cannot measure utility, and that becomes a big problem, a big challenge when it comes to the equimarginal principle. So, we need to find a theory which is more realistic in terms of looking at consumer choice, and that's where indifference curve comes. Indifference curve is based on the principle that like we cannot measure utility, but we can definitely rank different combinations. So, for example, if you ask me, do I like apples more than oranges? My answer will be yes, for example. And if you ask me by how much, my answer will be I don't know. But if I could do ranking, then basically by ranking combinations, we can actually build a consumer theory, or we can build sort of preference structure. So our goal is to look at preference structure. Let me write this: preference structure through ranking. Let's now talk about the definition of indifference curve. So what is indifference curve? Indifference curve is simply all the various combinations of two goods that give an equal amount of satisfaction or utility. So if I'm a consumer, if there is an indifference curve of two goods, all the various combinations that are on that indifference curve, I am ranking them equally in terms of utility. No one combination on that same indifference curve will have a higher utility. So let's see an example. Let's say I have two goods, apples and oranges, and I am looking at the indifference curve structure for those. So on my x-axis I have apples, and on my y-axis, let's say I have quantity of apples, quantity of oranges. And if I'm saying that there is an indifference curve out there, let's say indifference curve I naught, where you have all the combinations like combination A or combination B or any combination, let's say C, D, or even E, all these combinations are giving us the same satisfaction or utility, and that means that I am indifferent when I am choosing between these combinations. So there is no preference over, let's say, one over another. Let's give some values to these combinations. Let's say A is, let's say, 30 of oranges, and so for example 6 of apples, and on the other hand B is like 7 of apples while 24 of oranges. Now what you see is this: I'm saying that if I choose 30 oranges and 6 apples versus 24 oranges and 7 apples, I am indifferent, which means that I have no clear sort of preference when it comes to A and B. Similarly, if I go all the way to, like, for example, D, which is like, let's say, 10 of sort of oranges and 13 of apples, and vice versa, E, which is 8 of sort of oranges and 15 of apples, I am indifferent. So all points on the indifference curve, this consumer or I am indifferent, and that's why it's called an indifference curve. Now one more concept that we want to talk about before we move on is what are the various sort of characteristics of indifference curve, or what are the various principles that we need to remember when we are drawing an indifference curve. Now let's talk about the characteristics of indifference curve. The first characteristic of indifference curve that we want to discuss is the idea that all combinations have a utility level, and we can rank them. The fact that we can rank in sort of different combinations, that ability to do so means we can draw indifference curves. If I tell you that there is no way we can figure out the ranking of combinations, then this means we cannot draw indifference curves. So the fact that we can rank combinations is the reason why we can draw indifference curve. The second one that we want to discuss when it comes to the characteristics is the idea that more is better. More is better is the idea that we say that any indifference curve that is to the right, which means let's say I draw a diagram here, any indifference curve which is to the right, if more is better is true, then any indifference curve to the right will result in higher utility. So let's say this is oranges on my x-axis and apples, and let's say I am right now on indifference curve I0. But if more is better, this means any indifference curve to the right, like for example this indifference curve I1, will always result in a better sort of satisfaction or utility level, which means that more is better means, let's say if this was 30 and for example 7, and now for every 30 I can get for example 10 of oranges. This means indifference curve to the right is always preferred over indifference curve to the left, or indifference curve to the right will have a higher utility level than one on the left, because without sacrificing anything of apples I'm getting more of oranges, which means indifference curve to the right, or I1, is better than I0. And I can write that more is better means that any indifference curve to the right is resulting in higher utility. And if it is resulting in higher utility, that definitely means that we will prefer any indifference curve to the right over one to the left, because more is better. So for every 30 I'm getting more of oranges, and that means I will prefer this combination sort of x over y on any day. Similar to this thought is this the third one, which is that indifference curves do not cross. When we say indifference curve do not cross, I want to show you first why indifference curve crossing may be problematic for us. So let's say we have the diagram which is something like this. Let's say we have oranges and apples, and let's make indifference curve to cross to see why their crossing can be problematic. So let's say this is I0, and there is another indifference curve which is for example I1. Okay, and let's look at three combinations: combination A, combination B versus combination C. Now if I am on the same indifference curve, then basically the logic is that I have the same utility from combination A and B. So can I say this, that A is ranked equal to B? Why? Because they are on the same indifference curve I0, right? But A is always, or A is also equal to C because they are on the same indifference curve I1. Now you can see this, that if a consumer look at C versus B, and I draw this sort of point, then let's say if combination B was giving me 20 of apples and sort of 10 of oranges, while combination C is giving me same 20 of apples, but let's say 30 or rather 20 of oranges, then clearly combination B is worse, or combination C is preferred over combination B, because for the same 20 I'm getting more of oranges versus less of oranges. So I have to say this by looking at the diagram, that if more is better, then C is greater than B. But that doesn't make any logical sense, because if you look at it, if C is greater than B, then C can't be equal to A, because A is equal to B, B and A is equal to C. By that logic, B should be equal to C and not C greater than B. So in short, indifference curves do not cross, because if they do, then it is logically inconsistent for them to cross. The next one we want to talk about, number 4, is to do with the idea that indifference curves are convex to the origins. Let me write this. Indifference curves are convex to the origin. The reason why they are convex to the origin brings us to look at the first diagram. So when you go back to our first diagram, as you can see this, the convex to the origin means this kind of a shape where it is such that when I go from A to B, for example, I'm sacrificing 6 of oranges, but I'm getting 1 of apple. But look at this, when I go from here to D point, for example, from D to E, the sacrifice is -2 for a +2. So if I find out the slope here, my slope here is basically -6, which is change in y, over +1, which is change in y over change in x. So here my sacrifice is equal to -6. For every 1 apple, I am sacrificing 6 oranges. But as you go to from D to E point, look at this, the sacrifice here, because if I look at the slope, my sacrifice here will be for -2, which is change in y, over +2, which is going to be -1. So the slope is basically going down, the sacrifice is going down as I buy more and more of apples. And the reason is simply because of our utility theory, which says this, that as we buy more, or as we consume more and more of a good, the less we are willing to give up something else. So as I get more and more of apples, previously when I had very little apples, I was willing to sacrifice 6 oranges for 1 apple. But now when I have more apples, I have like 13 apples. Now for every 1 apple, I'm only willing to sacrifice 1 orange, and that is exactly why convex to the origin shape suggests to us, because if it isn't convex to the origin, it will not follow our diminishing marginal utility. So why is the curve convex to the origin? And the answer is because of the law of diminishing marginal utility, which means that as quantity rises, mu falls, and that's why we are sacrificing less, and that is exactly why our slope is reducing, which explains why our indifference curve is actually convex and not concave or even linear. Our next discussion is about the slope of the indifference curve, because slope tells an important concept of the what we call marginal rate of substitution. So when I look at this diagram that we just discussed, we can look at something called the marginal rate of substitution. So what is marginal rate of substitution? We say that marginal rate of substitution is simply the rate at which a consumer is willing to substitute one good for another. And you can see this, that when I go from A to B, the rate at which I'm sacrificing my sort of oranges for apples is, for every one orange I'm sacrificing six of for every one apple I'm sacrificing six of oranges, and that same rate of substitution goes to for every one sort of apple I'm only sacrificing one of orange. So marginal rate of substitution is simply our slope, and it tells us what's the rate at which we are sacrificing or willing to substitute one good for another. And we also say this marginal rate of substitution is simply MUX over MU of Y. In other words, in this case, since good X is apples, good Y is oranges, my slope or marginal rate of substitution is simply MU of apples over MU of oranges, which is MU of good on x-axis or MU of good on the y-axis. We are now in a position to discuss what we call our optimum consumption point. Let me write this: optimum consumption point. This optimum consumption point is the same as us as a consumer maximizing our total utility from a given budget. So if I'm a consumer, my goal is to maximize my total utility from a given budget, and that we say we can do that through our indifference curve. So that's one element that I'm going to bring here: indifference curve and our budget line. So budget line tells us all the various combinations that we could afford, but indifference curve tells us all the combinations that I am indifferent about. And as a consumer, I would like to consume along the highest possible indifference curve. Highest possible indifference curve means that the one indifference curve that is to the right will give me my maximum satisfaction than the one on the left. So as long as I could afford it, I would want to be on the highest possible indifference curve, which will help me achieve my goal of maximizing my total utility from a given budget. So now I'm going to put both the elements, budget line and indifference curve, on the same diagram. So let's see that. Let's say I have the two choices that I had before, which was basically oranges and apples, and let's say this is my budget line. I can afford all the various combination on this line. Now if my indifference curve is, for example, I naught versus indifference curve I1 versus indifference curve I2, I would love to be on indifference curve I2. The one on the right is always preferred to the ones on the left, which is I1 and I0. But the problem is this, that I2 is right now unaffordable given my budget line is this green budget line. So with this green budget line, I2 is unaffordable. So this is not a combination that I can afford, and that's why it's not a combination which is going to be considered right now. But I could totally buy combination, for example, A, or combination, for example, B and combination C. Why am I saying that? Because all these combinations A, B and C are on my budget line, and therefore they are affordable. So if a consumer has a choice of buying A, B and C, which one will he ultimately buy? Well, we know this, that the consumer is indifferent between A and B. So between A and B, he will say this: A is equal to B. because they are on the same indifference curve I naught. But C is preferred over A, and C is also preferred over B. Why? Because C is on a higher indifference curve. If more is better, then clearly C will be preferred over A and B. And as you can see, C is also affordable. So ultimately the combination that the consumer will end up choosing, we say this, is the combination where the budget line is tangent to the indifference curve. And the reason why a consumer will choose this combination is because the maximum possible satisfaction is always on the indifference curve, which is to the right and yet affordable. So combination C is such that this green budget line is tangent to the indifference curve I1, and beyond I1 I have all the unaffordable indifference curve, but I1 is the indifference curve that gives me the maximum possible satisfaction that I can buy from my limited income. Now at point C, what is important to see is that at C the slope of indifference curve is equal to the slope of the budget line. Now if the slope of the indifference curve is equal to the slope of the budget line, I can sort of say this, that mu of x over mu of y, which is the slope of the budget of the indifference curve, is equal to px over py, which is the slope of the budget line, which we've seen in the past videos. Now if mux over muy is equal to px over py, this is actually our equi-marginal principle, which we proved in our first video on utility. So mux, I can rewrite this, over px is equal to muy over py. So from the indifference curve, what we found out is the combination that a consumer will ultimately buy is the one where the indifference curve is tangent to the budget line, but that is also the combination where the slope of the indifference curve is equal to the slope of the budget line, and therefore mu of x over price of x is equal to mu of y over price of y, which means at this point C, let me go back to the diagram, at this point C, the equi-marginal principle is also true, which means that I am maximizing my total utility from my given budget. Now this point C is also what we call consumer equilibrium. So there are a lot of questions that come in exam there which will ask us about what is meant in economic theory by consumer equilibrium, and the answer to this one is that if you use indifference curve analysis, that is the point where the equi-marginal principle is true, and that is the point where basically we are saying that we will choose the indifference curve that is to the right and that is also affordable, which means it is tangent to the budget line that we have. So remember this, if there's a question about what is meant in economic theory about consumer equilibrium, that is exactly what we need to write, that for us economic analysis says this, that an indifference curve that is to the right of my budget line and is tangent to my budget line is the one which I will choose, which gives me the maximum possible satisfaction, and it is affordable, and it is the point where the equi-marginal principle is true, that is the slope of the budget line is equal to the slope of the indifference curve. Our last part of the discussion is about how we can use indifference curve to derive demand curves. Now we will make demand curves for two kinds of goods. One is what we call normal good, and another one is what we call inferior goods. And within inferior goods, we will look at inferior goods which are Giffen and those which are non-Giffen. And I will explain Giffen and non-Giffen in a later part of our discussion, but we are now about to use this theory to look at how demand curves can be derived. Let's start with our normal goods. We know that normal goods have what we call a downward sloping demand curve, which means that when the price of a good goes down, we notice that the quantity demanded goes up. And this basically, price going down, the quantity demanded going up, suggests to us that our demand curve for normal goods is downward sloping. And that is why when the price goes down, we notice the quantity demanded is going up. This price going down, quantity demanded going up, this is what we call our price effect. And the price effect is made up of two effects, which are called substitution effect plus what we say income effect. Substitution effect and income effect, we say they happen simultaneously, and that's why they make up our total price effect. So what is substitution effect? Substitution effect simply says this, that if the price of a good goes down, it will become relatively cheaper than its substitutes. Let me write this, relatively cheaper than substitutes. And because it becomes relatively cheaper than substitute, we will buy more of this good. So substitution effect simply says buy more because the good is becoming cheaper than the substitute. On the other hand, your income effect says this, that if the price of a good goes down, the real income or purchasing power, it goes up. And if the real income or purchasing power is going up, then we should buy more of this good if it is normal in nature, because normal goods by definition means normal in nature. So normal goods by definition mean that when our income go up, our demand should rise. And that, if that is true, then in the income effect, because the price is going down, my purchasing power go up, I am going to buy more of this good. So substitution effect says when the price goes down, I should buy more, and even income effect says buy more. I'm now going to show this same substitution effect and income effect through indifference curve. So when we draw our indifference curves and budget lines, I'm going to show how the price of a good going down results in us to buy more of this good. Whenever price of a good goes down, we learn from our budget line sort of discussion that the budget line will pivot out. So this is our apples, quantity of apples, and this is quantity of oranges. And let's say price of apples is going down. If the price of apples go down, we notice that our indifference curve will now become will shift pivotably out. So this is my new indifference curve when the price of apples has gone down. But when the price of apples go down, two things are happening, and we're saying both the substitution effect and income effect are happening. So first thing first is what we need to look at is that how can we find out the income effect and substitution effect. So in this line, when I look at this line, if this is my ultimate line which shows me my price effect, this ultimate line that shows me price effect has both the substitution effect and income effect. Somehow what I need to do is remove my income effect from this to find out my substitution effect. In other words, when I'm trying to find out my substitution effect, I need to keep, let me write this, keep income constant. So now keeping income constant means removing from this pink line, I want to remove my income to only isolate my substitution effect. So if I remove income and I say my income is removed, my budget line will move parallel backward. This pink budget line assume there is no change in real income, and therefore you can see this, that it is kind of like a telling us if I was previously at white line, on the white line, and now I'm on the pink line, on the orange line. So moving from the white to the orange line simply means apples are becoming relatively expensive than orange. But then from this orange line, I add my change in real income, that is your income effect. I ultimately go to the pink line, and this pink line basically has both the substitution effect and the income effect. So my first goal will be to look at our substitution effect. The way we look at our substitution effect is that we will make an indifference curve that will be tangent to the white and an orange line. So let me draw the graph of an indifference curve that is tangent to both these budget lines. So if I look at my indifference curve I naught, and let's say I was previously consuming Q1, okay, and so then price of apples fall, which made me buy more of apples just because they are becoming relatively expensive than orange. So if they are becoming relatively expensive than oranges, I am moving from combination A to combination B, and this move from combination A to combination B is simply my substitution effect. And the reason why I'm saying it's my substitution effect is because it's on the same indifference curve, which means that I'm indifferent between A and B, but I'm only buying more of B because it is becoming cheaper than apples. And the fact that it is on my new sort of budget line, it means that this budget line, orange budget line, is the one that only shows substitution effect. So if the price of a good goes down, I'm buying more of apples because it is becoming relatively cheaper. But we said this, that other than the substitution effect, which says that when the price goes down, substitution effect says buy more, my income effect also said, you know what, the good is normal in nature, and because the good is normal in nature, we should buy more of that good. So when you look at income effect, I'm now going to make my indifference curve which is on the new line, something like this, and I am going to now consume combination C, where my ultimate quantity is Q3. Now this Q2 to Q3 is what we call our income effect. So your substitution effect says when the price goes down, you buy more of that good because the good is becoming cheaper, and even the income effect is saying that because price has gone down, your real income has gone up, you should buy more of that good. How do we use this knowledge to make a demand curve? So lower down, let's say if I want to make the demand curve for apples, this is how it will look like. On my y-axis, I have price of apples. Let me write this, price of apples, and on my x-axis, I have quantity of apples. And I'm drawing right below the upper diagram because I'm going to use this knowledge that I have about quantities from the upper diagram. So when the price was, for example, high, I was buying Q1 because this was the quantity I was buying. So I'm buying Q1 when the price is high, let's call it P0. But when the price went down to sort of, let's say P1, I'm buying Q3. Where did I get this Q3 from? This Q3 is the same Q3 as this one. So if I join these 2 points together, if I join them together, I get myself what we call the demand curve for apples. And you can see this demand curve is downward sloping. And the reason why it's downward sloping is because both income effect and substitution effect is saying we should buy more of this good. So when you're looking at a demand curve for normal goods, it is downward sloping, and it is downward sloping because both both income effect and substitution effect says we should buy more of the good when the price of the good goes down. For inferior goods, I'm going to first look at what we call non-Giffen goods. So what are inferior goods? Well, inferior goods are those where when my income go up, I should buy less of them. So when you look at the price effect, which says this, that when the price of a good goes down, there is substitution effect, and there is income effect that happens. Substitution effect says this, let me say price is going down. Substitution effect says this, that because price is going down, it is becoming relatively expensive, we should buy more of this good. So there is no difference between substitution effect in a normal good and in an inferior good. But income effect will be different, because income effect says that when the price of a good goes down, you should buy less of this good as real income goes up when price falls. So what we say is that substitution effect is saying buy more, income effect is saying buy less, and so they kind of contradicting each other. Now the problem with inferior goods is this, that inferior goods are really low in price. The fact that they are so low that in price, that even though the price goes down, we will have an income effect. That income effect will be really small, and the reason is very simple. Because these goods are extremely cheap, they will not make significant impact on your income, and as a result, what we also say is that although income effect says buy less, but because the good is inferior, our substitution effect will always be greater than income effect. And such is the case that substitution effect is saying buy more, income effect is saying buy less, and because substitution effect is outweighing, let me write this, SE outweighs IE, so SE says buy more, IE says buy less, ultimately my price effect will say buy more, because our substitution effect is more powerful than income effect. And I want to show this concept through our indifference curve. So let's draw the indifference curve for inferior goods now. So the same sort of process will be done for our inferior goods. So now let's say our apples are not normal but inferior goods, and we are going to make the price of apples fall. So we will basically see the budget line to pivot out. So my initial budget line is, let's say, the white one, like this one, and let's say then the price of apples are going down, so my budget line becomes this pink one, and I'm also going to now remove my real income to differentiate between substitution and income effect. So I'm going to make a line which is parallel to my ultimate budget line, saying that this was my initial budget line, then the price effect will take us to this pink budget line, but I'm going to remove my change in real income to look at substitution effect first and then income effect later. The second thing we'll do is that we'll make an indifference curve that is tangent to the original line and the one where there is no income effect. So my initial sort of indifference curve will be like this. Now I'm consuming, for example, a point that is tangent to my indifference curve, because that's the rule where I'm maximizing my utility. So I'm at point A and the quantity is, let's say, Q1. When the price went down, substitution effect said buy more, so I'm buying more, so I go from A to B. But because the good is inferior, let me just write this substitution effect. But because the good is inferior, the problem that happens is this, that when I look at my my budget line, or the pink budget line, I will now make an indifference curve that is tangent to the budget line, but it is in between A and B. It is at this point C, where my income effect is telling me that I should buy less of this good as I go from Q2 to Q3. And the reason is simple, that because the good is inferior in nature, substitution effect is saying buy more, and income effect is saying buy less. But income effect, although it's moving in the opposite direction, it's not powerful enough to outweigh substitution effect, as the good is extremely cheap. And therefore I can say this, that substitution effect is greater than income effect, and that's why we're buying more of this good. I want to show the same thing through our demand curve, which will help us understand. So I'm going to make the demand curve for apples, and the demand curve for apples will have price of apples here, and on my x-axis I'm going to have quantity of apples, which is coming from the top diagram, and I'm buying Q1 before and I'm buying Q3 later. Look at this, guys. This quantity change is much smaller than the quantity change above, because there was income and substitution effect that was both adding to my price effect. But in this case, my only substitution effect is saying buy more, and income effect is reducing that effect, because income effect says I'm going to buy less of this good. So when I draw my diagram, it will be look like, let's say prices previously was like P0, I was buying rather P1, I was buying this quantity A, and then when the price went down to sort of P2, I'm buying B. So my demand curve will look like a downward sloping demand curve of gain, but kind of very inelastic. So it's still a downward sloping demand curve. If somebody asks you about elasticity, we can say this, that the normal goods might have a very elastic demand, because income and substitution effect, they work in the same direction and they sort of reinforce each other, while for the inferior goods, substitution effect may say buy more, but income effect is very little and move in the negative direction, and it says buy less. But both the normal good and inferior goods have what we call a downward sloping demand curve, which we need to understand. Our last discussion is about what we call Giffen goods. What are Giffen goods? Well, Giffen goods are kind of inferior goods. Let me write this. They are kind of inferior goods, which means that they have what we call negative sort of income effect. But the thing about them, which is differentiating them from the other kind of inferior goods or non-Giffen inferior goods, is that they are very, very low in price. But despite being very low in price, they actually also take up a large proportion of a consumer's expenditure. So these goods are extremely low in price, A. They are basically kind of inferior goods, B, but they take up a large proportion of consumers' income. A good example of this could be, like demand for a rice or low quality rice in somebody's sort of budget. Now, when the price of these goods sort of go down, the substitution effect should say we should buy more of these goods, because the price is going down, the rice is becoming relatively cheaper as compared to, let's say, bread. We should buy more of that good. But because these goods are sort of inferior in nature, your income effect says this, that when the price goes down, you should buy less of these goods because they are inferior in nature. So let me write this. So for our Giffen goods, the substitution effect says price goes down, price is going down, we should buy more of this good because it is becoming relatively cheaper than the substitutes. But income effect says this, that price is going down, because my real income is going up, I should buy less of this good. Now the tricky part here, or the part that we need to understand here, is this, that because these goods take a large proportion of consumers' income, let's say if I'm somebody who's really poor and I need rice, this rice is basically takes up a large proportion of my income because it is a necessity for me. My real income, actually my income effect will be much larger. So what we say is this, that once the Giffen goods become cheaper, people actually have a large income effect. So substitution effect says sort of buy more, income effect says buy less, and because the income effect is going to be large, we say that income effect end up being greater than substitution effect, or income effect end up outweighing substitution effect. And if income effect end up outweighing substitution effect, what we have is a very unique case where the price is going down, the quantity is also going down, and we have what we call, for the first time, an upward sloping demand curve. Why? Because the income effect is saying we should buy less of this good, in fact significantly less of this good. So poor person, when the rice becomes really cheap, he may end up cutting down the quantity of the rice he consumes, maybe move to a better brand, maybe consume more of bread, maybe eat more of meat, because now his price of rice is going down, of the lower quality. So how do I show that in terms of our indifference curve? Let's draw the diagram quickly. So following the same steps, you can see this, that if the price was previously, the budget line was previously the white line, when the price of apples go down, we move to this budget line, the pink budget line, and then we say this, that our we need to remove our income effect. So we will draw our budget line, which is going to be parallel to our sort of the ultimate sort of budget line, or the new budget line. Now the white line is where I am originally going to be, the orange line is where I will be after my substitution effect, and the pink line is where I will be after my price effect. So the way I'm going to make my indifference curve is that I'm going to be like at point sort of here. So my initial point is point A, and I'm buying Q1. When the price goes down, substitution effect says buy more, because the good is becoming cheaper. Substitution effect basically always say buy more because the good is becoming cheaper. Now income effect says, wait a minute, this is an inferior good. In fact, it's a Giffen good, which is inferior good but extremely low price. Income effect will say buy less of this good, in fact significantly less of this good. So we will ultimately move from indifference curve I0, I'm going to move to indifference curve I1. But see what is happening here. My new indifference curve is drawn in such a manner that I have ultimately ended up being at Q3, which is even below my first point. So the income effect is much more powerful, so much so that it has completely outweighed my substitution effect. So if I draw the demand curve right below, when the price is, for example, high, let's say P1, I am buying Q1. So this is my demand for apples. But when the price sort of goes down to P2, I am buying this Q3 quantity. So if I join the 2 points together, I get myself what we call a demand curve, which is upward sloping. So this is my, let me zoom this picture. This is my, let me also label it properly. This is my price of apples. This is my quantity of apples. And I have what we call an upward sloping demand curve, where I ended up from point A to point B. So if I give you a quick summary, for normal goods, the demand curve is downward sloping. For inferior goods, the demand curve is downward sloping. But for Giffen goods, the demand curve is upward sloping. So Giffen goods is the only sort of demand curve where is the only good where the demand curve will be upward sloping. The second thing is this, that for normal goods, substitution effect and income effect, it reinforces each other. But for inferior good, the substitution effect and income effect, they move in the different directions. But because income effect is small, substitution effect kind of outweighs income effect, and that's why demand curve is downward sloping. But in the case of Giffen goods, the substitution effect is less powerful than the income effect. Income effect ends up outweighing substitution effect, and that's why we will have an upward sloping demand for Giffen goods.